is this? Okay, let's start fresh. Okay, so so when you install a virtual machine on a device, what happens is it will have this particular virtual machine will have a configuration file. I'll just show you that configuration files as well, right? So this configuration file consists of the hard-coded OUI what the IEEE might have provided to the virtual machine team, right? Okay. Now this particular OUI will be fixed for that particular virtual machine, that particular organization, whoever provided this virtual machine. However, whatever next 3 bytes of information is there. So this is the 6 byte of the MAC address what we have got. So the 3 bytes is stored for the OUI, the organizational specific indicator, and then we have the vendor specific indicator there. So that is also 3 bytes. So that is how they will get unique MAC addresses. But for example, you are hosting 2 or 3 virtual machines on your device. So you have a Windows machine, you have installed a virtual machine on it, and you have 4 virtual machines installed on your device, and you're testing something. Let's say you're trying to test your network, or you're trying to create an application and check the behavior when there is same MAC address on multiple devices. So what you can do is you can modify this MAC address. You can keep this MAC address same, this MAC address also same, this also same, this also same. So it depends upon you, because virtual machine is within your control. So it does not interfere with your base machine. It just utilizes the base machine's kernel in order to install itself on that particular machine. That's it. The moment it has done that job, it's going to use all the programs and features of the base machine in order to supply whatever you are requesting the virtual machine to do. You can install
Yes,
any operating system on it.
yes, I got it. No, thank
Right.
you.
So, regarding virtual machine, let me. I think I have got some virtual machines. Let me see. Okay. Okay. So yeah, I have got virtual machine. Let me present my screen to show you how that OUI actually works. Right. So I believe we are able to see the VMware workstation screen now. So in
Yes,
this, I have got some 3 virtual machines which I have configured here. So one is a Mac, one is Windows, and one is my organization specific virtual machine here, right? So if I click here and I go to the settings, so I'm not going to turn the virtual machine on, but I'll show you how the network adapter, the network interface card, has that MAC address which is stagnant. The OUI portion is stagnant for all these 3 virtual machines. If I go to the advanced settings here, you can see the MAC address here. And note that the initial 3 bytes 000C and 29, this will remain same for all these 3 virtual machines which I am going to show you. The other 3 bytes will be variable. as I explained just now, that OUI is specific to the vendor. So here our vendor is virtual machine, the VMware. So this company is provided by the IEEE that this is your MAC address, use this only, right? So if I close this and go to another virtual machine and I show you the network adapter of that, I have two adapters on this virtual machine. If I click on advanced, you can see this 00, 0C and 29. And this is variable. Clear? Now I will, sorry, I will show you another network adapter on the same virtual machine. It will have a different MAC address, but the OUI will remain same here. 00, 0C, 29, but the complete MAC address is unique. So this is how that uniqueness comes for the organization, so for the MAC address, right? I hope this is clear.
Yes, I cleared that. Thank you.
Now, any further queries?
Sir, yesterday we have discussed about ARP replay
Mm-hmm.
and how ARP works.
Mm-hmm.
And in this, I got this doubt like ARP is nothing but address resolution protocol. Here, address means physical address,
Yes,
and here ARP will tell about the only information the packets like IP address to MAC address to IP address.
exactly. So our job is to find from IP, for whatever IP, what is the MAC address. Simple, right? So
Yes, sir.
based
And
on,
you told about how it works, like uh, when the source will become destination address and destination become source address, and MAC also become the same thing you told yesterday.
exactly, that is what will happen, right? So it is simple that when you are sending the packets from one router to another router, and then another router to the third router. So for this router, the source is this router only, the destination is this one, right? The moment the packets reach this particular destination, the MAC address and all the relevant IP and TCP headers, they have to change. Not the TCP header, but IP and the layer 2 headers have to change. So our Ethernet header also will change, and it will change to this. So the source will become this MAC address, the destination will become this MAC address. So that is how it will flow throughout the path.
Okay, sir. And you told ARP is not ARP didn't provide any security. Then how?
Uh, Sorry, Nagarajan, can you repeat?
You told that ARP is not it doesn't provide any security and all, because you take an example like if we go to any coffee day shop, like we if we try to connect with that Wi-Fi, uh, ARP will not give any security, and there will be DORA process will be running DHCP.
No, no, it's not like that. So what I meant from that particular statement is how a hacker can leverage this ARP, and later he can exploit that particular user, right? So ARP is nothing but address resolution protocol for what? For finding out the MAC address of any device which has a IP, right? So when you are in a internet shop or in a vulnerable locality where people are actually having access to the main router, so let's assume that this router is not password protected, so anybody can join to this particular network. So I told you in ARP what happens is, let's say there are hundreds of devices connected to the single router here. So, in order to find out the MAC address of this particular device or any device in the network, what your device does is it sends a ARP request packet. And what does it send along with it? It sends that in the layer 2, it sends a broadcast message. So FF will be the destination, right? So it doesn't know where it has to go. So simply it sends this particular request to all of the devices within the network. And when this happens, among these three devices, anyone could be the hacker, right? What they will do is they will get to know that there is somebody new in the network. So when there are somebody new in the network, they will make a note of, obviously their hacking tool will make a note of the IP address and the MAC address relevant to that. Once that is done, this guy will start behaving as a DHCP server. And this doesn't happen like you and me can do this. It's not like that. There are specific tools for it, right? There are specific tools and configurations for it. I'm just taking this as an example, right? So now general job of this router is to send the DHCP, the DORA request, whatever it is, the DHCP process should happen by this router only, because this is the one which has to provide the IP address to all the devices within the network, as this is a router. But what if this device who is running a hacking tool or a rootkit on the device? So when somebody runs any sort of hacking tool, it's called as a rootkit. So when they run that sort of a rootkit on their own device, their device starts behaving as a DHCP provider. So when that happens, and when this guy will start a discover process, that packet reaches here also, and the same packet reaches here also, right? So now what will happen is, if I take it a little bit in a complex manner, what this guy does is this guy will start sending lot of packets of DHCP to this guy, so that this guy doesn't have any more pools, any more IP addresses to provide to this user. So this end user has only one way to get IP address, and that is to get the IP from this hacker. Now what will happen? This hacker will provide him one IP address, so that this guy connects to only the hacker device, not to the router. So through router, he is connected to the hacker device, and from hacker device, he is sending the connection out to the internet, right? So you see now that once they are connected to this particular guy, this guy has overall control on the data what this guy is trying to exchange. And that is what I was trying to tell yesterday. This is the reason why we tell that ARP is not a secure protocol. And there is no way you can provide security to this protocol, because it's acting in layer 2. So we don't have that sort of a control there. For that reason, and only that reason, bigger organizations have lot of devices within their network which are ranging from switches, then this is connected to a router, then this is connected to a firewall, and so on and so forth, right? So they have to provide security to this switch, and this switch will be provided security using port security, right? The router, which is acting in the network layer, will have access control list policies in order to provide security. What is access control list policy? It's nothing but you are telling to the router that only accept connection from so and so IP address, and deny or drop the request from any other IP addresses which are not listed within the access control list. Simple. The firewall is the place where the traffic is inspected. And by inspection, what I mean is it tries to see where the traffic is actually going, who is the source, who is the destination, whether we have to allow the traffic or not. So this is the endpoint of an organization. So an organization will have a firewall before any traffic actually enters this organization. Once it enters, it flows via router. After router, it flows via switch. And from switch, it is connected to an access point. Right? And access point is a wireless mechanism via which the users will be connected to the internet. Right? This is just a basic high level thing. But I hope you understood what I was trying to tell here.
Yes, sir, I got it. But here I understood that this hacker will use the flow of discover packets to the client, Again, it DHCP access first come first serve. Like it will take whatever the packet first comes, it will take the IP address. If the user uses VPN, how it works, sir?
If the user uses VPN, yeah.
Yes.
So when a user uses VPN, VPN are of different ways. Like number one is if they are using a virtual private network, what happens is there is a sort of this thing there that is called as encryption, right? What is
Okay.
encryption? It is nothing but locking your data using encryption algorithms. So you are locking that data. That's it, simple. So few VPN providers provide this encryption, right? There are another VPN service providers which don't provide encryption, although they provide a sort of a HTTP tunnel. So what does this HTTP tunnel do? For this user, when this user tries to send the traffic is not destined to the actual destination when he sends the traffic here, right? So they use HTTP connect method, right? So HTTP connect method is nothing but you are informing the server. Let's say this user is sitting here, he is connected to a Wi-Fi network, free Wi-Fi network, and his device is connected to some VPN provider, right? Some VPN provider, and from here it will go to the internet, right? So how this will protect his data is that he or she is going to send the traffic to this router. Obviously, they are vulnerable already, right? So when they are sending the request, they are sending it towards this VPN, not directly towards this. You're getting my point? What I'm trying to tell is when you use a VPN which is HTTP based, I'm not talking about encryption based, I'm talking about HTTP based. What happens is the entire HTTP packet, whatever you're trying to request, has an additional header. It has an additional header which says that once this particular packet reaches this VPN provider, it has to connect, HTTP connect. So you are sending a HTTP connect request telling that connect me to google.com, right? So what happens is in the source and in the destination, what you see is the source is the user's IP, private IP, and the destination you will see the VPN IP address. You will not see the destination of the google.com. So that is how VPN service providers actually evade government laws. So you might have observed that there are multiple URLs in India that are blocked from accessing. And in order to do in the recent time, I think there was, PUBG also was blocked, I think, recently, or some other applications as well. So for that, people started using free VPN service providers, right? So this particular VPN service does the job of this. So it sends each and every packet destined to this VPN service. So when somebody is actually taking a packet capture, or maybe they are utilizing some firewall technology to check what exactly is happening with the packets, what happens is the firewall will only see the source and destination. It will not see what it is carrying inside, right? So in our scenario, how we evade the government laws is that the source will be obviously you being in India, and you're trying to connect to some server in China. Let's say you're trying to connect to some XYZ server in China, which is actually blocked in India, right? But the destination, which is in the outer packet of your IP header, will have another destination that is based out of India only. And from there, the traffic will go out. Got it? Uh,
Yes, sir.
yeah, we will cover
Uh,
the
I
concept of
have uh,
VPN and all later.
I have a doubt, sir. Will my VPN proxy my IP address?
Yes, exactly, it will.
Okay,
So
because
yeah,
uh, because you told that cafe example in that the hacker will use DHCP packet, so he can collect my IP address and all. If I use VPN, that will be good for us, right? At that place, at that time?
Yes and no. So that depends on the kind of tool hacker is using. So let's say this VPN is encrypted. You are sure that your VPN is encrypted and there is no way the hacker can actually exploit this encrypted VPN. But there is a way to exploit this VPN. How? Initially, when a VPN establishes connection, it sends the client hello and everything. So the TCP three-way handshake happens, and then the SSL handshake happens between your machine and the VPN service data center, right? So initially, if this particular negotiation is captured by the hacker, then what is the use of having this encryption at all? Because the hacker is aware that you are negotiating with the VPN service provider, and the hacker will collect everything. He will collect the client hello details, he will collect the server hello details, and he will also collect the server certificate, right? Finally, after these three, what is remaining? He has the keys altogether, so he can devise the key automatically based on the negotiations what the client and server has done, right? Once the decryption key is with the hacker, he is going to capture all the packets, and once the packets are captured, he's going to save the packet and decrypt that using those keys, right? So there is something called in Wireshark called as keylogger. I'll maybe, if we get some time and we have some spare time remaining, I'll show you this exercise. So basically, what happens is the hacker will gain access to the client random keys on your machine. And once they gain access to this client random keys, they are going to decrypt the packets using that client random, right? So when you send a client hello packet, there is something called as client random. When you receive a server packet, you receive the server random, right? And based on the client random and server random, and whatever cipher suits these both have negotiated, based on that, they are going to devise a key, right? So the server also will devise a key, and the client also will devise a key. And these keys are used to encrypt and decrypt the traffic at their end. But if there is someone man in the middle and already knows what is the negotiation happening here, so it's not difficult job for the hacker to devise these keys. He'll have both the keys with him handy, right? So there is no meaning in having a VPN enabled and then you go to a free Wi-Fi network hotspot and then you try to use it. In general terms, nobody is going to exploit it when it's an encrypted VPN. That's not an easy job. But since you mentioned, I told that how we can actually exploit it. We can do this,
Got it, sir.
right? So HTTP tunnel based VPNs, they are not going to be that much encrypted. So this is way easier to exploit the user. We'll come to the concept of VPNs in the security module. Not a problem. Right. Any further doubts? Okay. Great. So today I didn't want to take much of your time, and I wanted to just cover up a basic brief about a concept. Just a second. Where is this? Okay. So we have been discussing since the beginning of the session, right, that there are network devices. Just now also we discussed about a network device. I told you switch. I told you router until now. I told you NIC, the network interface card. But what are these? What do they actually do? We are not sure, right? So I have a small image here. Just a second. Bring that image here. Okay. So if you see this, most of us might have seen this. We might have seen this, right? And I don't think so any one of you might have seen this and whatever I haven't ticked. But this maybe if you go to a computer hardware shop, you might have seen it, but you wouldn't be aware what it is exactly, right? So these are the networking devices, and along with this, we have firewalls. So in infrastructure, this is what plays the major role. Router plays a major role, switch plays a major role, right? And that's it. Those three play a major role. The network interface card, of course, because this is installed on the user machine. Now, how does a firewall look like? Let me get an image. Let me get a Cisco firewall image. There are very big firewalls, and these days, since the technology has, it has improved, we have very small devices which act as next gen firewalls. Okay, so I hope this should do it. Okay, I think this is good. Let me use this. Right. So you can see here that these are the firewalls what we have got. The ASA firewall, and this is the version number they have got. This is Cisco series of firewalls, ASA. You might get posted in your, like in your interviews, they might ask you if you have worked over a firewall, which firewall it is. You can literally use any number of any version, something you can mention in the interview, not a problem. But the only thing is you must be aware what a firewall actually does. Right? So we'll get back to that point. Now here we see something called as Soho, we see something called as branch office, internet edge, campus, and data center. What are these? So these are the network topologies, right? So network topologies. What is a network topology? Network topology is nothing but using the combination of all these networking devices within for your requirement. So let's say you have a Soho network topology. What is Soho? It is nothing but small office home network, right? So that is the full form of Soho. That's it. Now, this is something which you are going to use up for a very small organization. Let's say you are building your organization from scratch now, right? So you are investing in your organization. You have a startup, and only 5 or 6 employees are there, or to the most there will be 20 employees within your office. But still, you want to have security for your data for whatever work you are trying to do. So definitely, you are going to prefer this particular firewall here. So this firewall, it shows you how much bandwidth it can carry. Right? You can see over here 150 MB per second is the maximum bandwidth it can support at a time. So per second, it is only capable of 150 MB of data to inspect, to apply policies, to check on that and all. Right? Similarly, if you move from the small home office and create a little bit bigger organization, let's say you have 100 to 500 of users in your organization, you can use this firewall. So on and so forth. The moment your organization size increases, you go to the internet edge devices, then you go to the campus sort of a network, and then you go to the data center sort of a network, like we have discussed for Microsoft and Google servers. In in United States, we have big Google and Microsoft servers. So they use this kind of big devices. They don't look that big, they are small, but their capability of transmitting the data is huge at a time. You can see here 20 Gbps, so gigabits per second, right? So gigabits is nothing but 1000 bits per second they can see, right? Now, if you see here, we have discussed about firewall. Now, what is the use of a router? So this should be clear by now, right? So what does a router actually do? Simple. You are just trying to route the packet on the logical address mechanism. That's it. So router helps you route the packets within the layer 3 according to whatever protocols the router is configured with. Simple, right? Now we'll come to a concept of switch. So what does switch do? So up until now we have learned about ARP, we have learned about MAC addresses. What is the use of that? If we are unable to route the packets according to the physical address, there is no meaning learning that concept at all, right? So in order to route the packets from physical devices to physical devices, we use a switch, right? So we call it as layer 2 device, right? So what is its job? Its job is simple. It just checks the uh, Ethernet header or the MAC header, whatever is attached to the IP packet before and after it, and route the packets accordingly. It plays a very important role in an organization, right? We have seen issues within an organization where if the switch port, so let's take this image over here. You can see this image, right? Let's zoom in. Yeah. So if you see this image, so if you see here, there are ports here, right? And having these many ports allows the end users or the organizations to utilize the network traffic in a very proper way. So the main important role of this switch is to create VLANs. VLANs is nothing but the virtual LAN segments. LAN is nothing but local area network, right? So you will be configuring this switch and you will be attaching the Ethernet port here, whatever RJ45 jack we have got, that particular port, that particular Ethernet wire, you will be connecting it to the router, right? So that it gets internet towards it. And then this particular port will have the data for the internet. This particular port will go to a access point where you will be configuring a VLAN, right? So once you configure a VLAN, only the users who are having that particular VLAN will be able to communicate with each other. Outside this scope, they will not be able to communicate. We'll come to the concept of VLAN, but just you can make a note of it that switch is capable of this. So this is the importance of a switch, right? And this switch also is helpful in order to avoid layer 2 packet looping. Layer 2 packet looping. So I told you in layer 3, that is in IP, we have time to live packet. So let's say your hops are 120 and after 120 the packet will die, right? So in a similar fashion, what happens with layer 2 is, what if, let's take an example. What if we have around, so what if we have around hundreds of machines, right? And you are sitting over here, okay? And you start broadcasting the packet. So what's the time limit that that particular packet drops? Because if you don't have a time limit, let's take a very small example. Let's draw this triangle here. Only three devices are here, and this guy over here, right? This guy over here initiates a broadcast packet. Now, how does broadcast packet move? It goes to the next destination. Since the destination is FFFFF, it is going to again send it to this one. This packet will be again sent to this one. And when this packet is being sent to this particular device, it will also send it to this particular device. So you see how much network congestion is there. Like that, this will keep on revolving inside only. So this will create network congestion. And because of network congestion, you will have internet slowness, poor performance. You will not be able to communicate properly. You will not be able to use internet in a proper manner. Just because of a switch not having a proper logic on it, it is going to cause this much big issue. And that's the reason why bigger organizations have a lot of security over switch, and they configure the switches in a very proper way, right? So we'll come to the concept of this particular avoiding the looping of the packet concept, but you can make a note of the two protocols, what how it does, that is STP, right, and RSTP. So STP stands for Spanning Tree Protocol. RSTP stands for Rapid Spanning Tree Protocol. So these two protocols' job is to avoid the layer 2 packet looping, right? So once they avoid the looping, we are freeing the network from the congestion at layer 2 level. Because if there are multiple packets of the same bytes of information looping around your network, you will not be able to send the actual packet which you actually want the destination to receive, right? So that is the main job and role of switch. So the important of switch is what? Number one, VLAN. Number two, avoiding the loopings. Avoiding looping using which protocols? It is STP and it is RSTP, right? You will be configuring this. If in case we have a chance, we'll try to configure VLANs and STP and RSTP, but I'll try to definitely show you how this actually works via video or something, at least, because if time is a constraint for us, right? If I'm able to get the lab setup, I believe I have the lab setup for this, but not sure. If I have a lab setup for this one, I'll show you how the VLANs and all are properly created and how they look like, right? So we'll configure and we'll try that. Okay, so that's about switch, and the basic details about router you are aware that we've been discussing from the beginning, right? So now next important concept, that is our NIC. What does this network interface card do? Right, it is this simple thing. I just showed you on my virtual machine that I went to a network adapter and I went to the settings of it. So that setting is nothing but this NIC, right? It consists of the TCP IP stack. I told you from the beginning that there is a TCP IP stack on your device. It is stored within your machine and all. It is stored on this small piece of hardware model, right? So this network interface card consists of all the information relevant for your device to communicate to the internet. So it will have the basic TCP IP stack and other control channel and data channel mechanisms, right? So this particular network interface card, due to the technology being improved, this particular port is changing from time to time. So we generally use that there are some connectors for Mac devices, right? You're connecting a Type C cable. You're connecting a Type C cable to a RJ45 jack, right? I believe I have an image for RJ45. Just a minute. RJ45 is nothing but the same device, the same connector which we see. Okay, I have it here. Just a second. here. Okay, let me get it from Google better. So I think we can cover a concept also here. Right. So this is what is a RJ45 pinout looks like. Right. At our home, when an internet service provider person comes, he cuts the wire and then he arranges those pins within this particular layer. So he arranges them according to this particular coloring order, and each coloring order has one particular standard code for it. So T568B order is this. So initially it should be white and orange. The second pinout should be just orange. Then the next should be white and green, and then it should be blue, then white and blue, then it should be green, then it should be white brown, and then it should be brown. Now, what's the importance of this pinout being like this? So when we talk about cabling, number one thing is there are two types of cabling, that is straight cable, right? And number two is crossover cable. You can make a note of it. Crossover cable, right? So what's the job of straight cabling and what's the job of crossover cabling? Let's assume that you want to connect, okay. So let's assume that you want to connect the router to the another router, right? So if you want to connect a router to another router, what you will be simply doing is you will be using a straight cable, right? So in straight cable, what happens is the pinouts for both the ends. This is the wire and this is the pin what we are looking at here. So by pin I mean only this section, right? So this pin is here and this pin will be here. So you're trying to connect a router to a router. So when you want to do that, it is going to be connected using the same pin side on both the sides of that particular Ethernet cable, right? The reason why is because cables, they have electrical connection in them, right? So they transmit electrical energies. So when they are transmitting those electrical energies through them, during transmission, what happens is there is something called as electromagnetic force and all that interfere that particular uh, data, whatever we are trying to send from one node to the another node, right? In order to protect that data, these cables are covered with the shields and all, that is fine. But when they reach out to similar devices, the input and the output data should be read by those similar devices on the same port. Otherwise, there is no meaning of sending the data to the similar devices. And that is the reason why we use straight cable for connecting to same devices, right? Now, uh, what if you want to connect your router to your laptop directly? In this scenario, you will have one pin out here and another pin out 568A right here. and then you will be connecting it. So that is called as crossover cabling. Right? So if I show you an image for the pinout structure, right? So if you see here in this image, this one, there is a pinout structure for all the 8 pins we have got for T568A and 568B, right? So in simple things, what you can do is, if you write the color combination for a crossover cabling, how you will be doing is 1, 2, 3, 4, 5, 6, 7, and 8, right? And for 568B, you will be writing down 1, 2, 3, 4, 5, 6, 7, and 8. So in simple terms, what happens is you will be connecting it like this. So you see here in this diagram, the 568A is here and 568B is here, right? So what happens is you are connecting the first pin out of 568A to the third pin out of 568B here, right? Similarly, you are connecting the second one to the sixth one. So second one to the sixth one. This is how the data will flow when they are crossed. So once they do this particular change, this is how the data is flowing when they connect. So when you are connecting the data here, when you are connecting the cable here, and when you're connecting the cable here, the data is flowing like that. So from this particular cable here, it is trying to flow towards the 8th pin out of this particular cable, right? At home, you might have routers. So what you can do post the session is you can remove that particular Ethernet cable from that and check what color wire is that. So you will have very minute wires. Maybe you might need some magnifier, or maybe you can zoom it using your camera lens. But you will see this color combination only. It could be either 568A or it could be either 568B, right? That depends. But this is how the color combination goes. So 1 to 3, 2 to 6, and then 3 to 1. Where is this? Yeah, 3 to 1. And then what we have, 4 to 4, 5 to 5, 6 to 2, 8, and I think 7 to 7 and 8 to 8. Yeah, 7 to 7 and 8 to 8. So for us, it is 568A here, sorry, B here, and 568A here. So this is how it is uh, going to send the data, because this is the crossover cabling. But if it's a straight cable, the thing is simple: 1, 2, 3, 4, so on and so forth until 8. 1, 2, 3, 4, so on and so forth until 8. Everything is connected straight. No change. Clear? This color combination and all is not much important. Nobody is going to ask you what is the color of the first pinout, second pinout, third pinout, fourth pinout. No, they are going to ask you the standards of this particular pinouts. So this is important. 568A and 568B, and the concept why. Why crossover? Why straight? Right? Straight, according to its meaning, it's simple, that you are going to connect similar devices. Crossover, you are going to connect dissimilar devices. That's it. Clear? Now, if I show you a proper image, I think, okay, let me show you this. Right. So if you see this image, you can see the pinouts here. So you can see the pinouts here 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8 for the connector 568A and for the connector 568B. Right? And a little bit of information about those electrical wires. That's it. So what does that initial wire do and all? That's not relevant to us. Right? Now the straight cable pinout is what is shown here. That is 1 to 1, 2 to 2, 3 to 3, like that. And the crossover cable pinout is shown here. Right? So that is how the cabling works. Okay, now we'll try to discuss a little bit about the next device. What we have got there is a hub. So here in this image, another important thing is for us, where is hub here? Yeah, here. So hub, what does this do? It's nothing but it's going to repeat all the signals whatever received on this particular port. So it's like this particular device is broadcasting whatever traffic is coming here, it is just trying to send it to all the ports. So in simple terminology, this particular device is not intelligent. Right? It is not aware where to send the traffic and all. It is just doing the job of sending the traffic from one whatever it is receiving, it is just dumping it out of all the ports whatever it has got. Right? Where will you use a hub? It's simple. That for example, if you have a router, right, and it only has 4 ports in that, right, and one of the port is used by the ISP, you only have 3 separate ports here, but you want another 3 or 4. You bring in a hub and attach it to that. Once you attach that hub here on this particular port, you have another 3 ports remaining. Right? So that's the major job of hub. That's it. Okay. Now we see something called as bridge here. So its core job is also in conjunction with the switch. So in general sense, these days nobody uses a bridge separately within their infra. They use something called as L3 switch. Important. So what does L3 switch mean? It means that it has the capability of routing the packets in the layer 3 layer. That is, it is capable of a router. It is able to route the packets in the layer 2. That is, it is acting as a switch also. And it is acting as a bridge also. So switch does the job of sending the traffic in the layer 2 from one particular device to another device. So what does bridge do? Bridge filters this contents. Right? This is not required concept, but it is something which is in the L3 switch. But still, it is better to just learn what a bridge does. It's just similar like switch, but it just filters the content based on the MAC addresses. That's it. Switch does the job of transporting Bridge does the job of filtering the content. Now, if you combine the combination of a bridge switch and a router, it is an L3 switch. Right? I think I have a diagram, maybe how to. Okay, let me show you this diagram. How in network actually it is connected. So you see here, for internet, the obviously this particular router is connected to your ISP, and before that it is sorry, not like this will diagram. Yeah, so it is connected to your firewall first, and then it is connected to your ISP, internet service. So this is an organization, let's assume. So this organization, this is the first floor, this is the second floor, right? So you can see all the devices what we just discussed in working here. So we are aware that devices are there, that's fine. But now the job of firewall is to allow is the traffic or deny it. So if there are no rules to allow a certain amount of traffic, then it will not be allowed within your organization. So your organization is safe, right? So what if the traffic actually comes inside via the router? So it has come inside the router. How is the traffic is now being routed to first floor, second floor, third floor, so on and so forth, right? So this router will send the packets in the layer 3, and the job of our switch is to send the packets in the layer 2. The hub is nothing but is connecting this switch ports so that it can be connected to multiple devices. So in our scenario, we are not using any wireless medium. That's the reason why we have all cables. And that is the reason why hubs are also come into picture here, right? So we are connecting this device, we are connecting this device. Now this device is used, is connected to a bridge so that this particular device acts, whatever this device has on it, like whatever ARC table, whatever MAC table it has got on it, that will be mimicked here. As I just told you, bridge filters based on MAC. So it is going to store that information, and whatever traffic is trying to come through this particular line here, it's going to also be provided to this particular devices as well, right? Not a confusing part. It's just that we are attaching multiple devices for our requirement. That's it. In general, organizations use a next gen firewall, and then they use internal routers, right? They can use any Cisco router, right? And then the traffic is then sent to a Cisco switch, which actually is incorporated within the router only. Then it goes to the access points. So what are access points? Now in this diagram, I showed you everything is cabled. What if, let's assume that this diagram here, it is connected with an access point, which is having a Wi-Fi antenna. Now this access point, its job is to repeat whatever the signal is coming from this router here. So it's not a easy job to purchase a very costly Wi-Fi router for a big organization and install that on each and every floor. That's not going to work. So economy is something which is important for organizations. That is the reason why they will have a bigger router at the start of their organizational network. From there, it will be sent to a switch or the hubs, and then it will be connected to access point on each and every floor. Access points are nothing but whatever routers you have at your home, that also can act as access points, right? So access point does the job of just extending the signal. So it is like a extender. So at your home, I believe some of you might have tried that your home is not getting proper internet supply or something in some of the locations of your home. Then what do? We do not like purchase a new router or something. We can install access points. So what we are currently trying to do with this architecture is we are going to grab whatever traffic is coming via this line to this particular access point, right? And if there is a wireless device, let's say there is a mobile phone, it will connect to this access point and will have access to internet with good speeds, because this access point is receiving good internet speed via the line cable, the LAN cable here, through the router only. So whatever data packets are flowing, they will be flowing via the bits and pieces within that particular frequency. So Wi-Fi will be using frequencies, right? 802 frequency it will be using. So this particular frequency will be transmitted back to your router via the LAN cable. And that is how it will go out, come inside, and whatever data packets are supposed to go to the device, they will come like this, right? So that's the job of the hub, the access point, right? Now, so what does this modem do? So we have an image here for modem, which is now long gone and a traditional mechanism, but still it is nothing but to modulate, or basically to convert the digital signal to the analog signal, right? So what does it do? So let's say there is a device here, it is connected to a modem here, right? And this modem is connected via a telephone line, not a LAN cable, right? And then we have another modem here and another device here. Now telephone line does not carry digital signals, does not carry zeros and ones, right? It carries signal in the form of analog signals, right? So whatever analog signal is there, that will be converted to the digital signal using the modems, right? So in earlier times, in earlier days, we used to get internet and calling functionalities using the telephone lines only. I believe all of you at your home might have those telephone line within your rooms, right? Within your rooms, you might have some telephone line RJ45 jacks, right? Those were meant for that. So earlier the concept was that internet will be supplied to your overall home via the telephone line, and it will be cabled somewhere in the ground floor, somewhere just there it will be there, right? And that internet supply, you can get access to that internal supply and also the telephone supply using that cable within your rooms inside. So there was no concept of Wi-Fi and all that time. But due to the advent of all of these devices and the cheaper cost of the routers, we are able to now send the digital signals directly instead of using a modem, right? So this modem concept was long in maybe 15 or 20 years back when I had a Ticona internal supply. I am not sure how many of you are aware of Ticona ISP, but this ISP used to supply this modem. They used to supply a modem, a router, right? And they used to have that connectivity at the top of your house. So that's about modems, right? So modems, NICs, repeater and hub do the same job, and gateway is nothing but you are whatever you are trying to connect, you are making it as a gateway. That's it. So this particular thing also has the job of hub and repeaters. Not majorly important. Important are NIC, router, switch, bridge, right? And the layer 3 switch, what I have told, the concept of layer 3 switch. So these are important. And the firewall, obviously. So any doubts, guys? I hope this RJ45 pinout is also clear. It's a simple thing. You can visit Google, check the color pinout. It's just that the straight and crossover cabling is what is important for you to understand. Why we use a straight and why we use the crossover, right? Any doubts? because this will complete our OSI model and the basic devices in the physical and hardware layer, whatever we have got, right? What would be remaining is, yeah, nothing much. Maybe in the next session we'll try to learn about the topologies, because I told you today about LAN, I told you today about SOHO, but not discussed a little bit about it. So we'll just take some half an hour or some time in the next session and complete that as well. So what is the LAN topology and all? So the different topologies in a network, not required to be learned in depth, but the basic idea is important. And among which LAN, WAN, wireless LAN, right, and CAN, MAN. So these are something which comes into topologies. We'll discuss about this, right? And we have different network topologies as well, like mesh topology, star topology, so bus topology. So we'll have to look into that as well. So it's going to take another 1 or 2 sessions to complete it completely, and then maybe we'll jump into the subnetting concept. But I hope these devices and all whatever we have discussed in the physical layer is clear as of now, right? Because in networking, any job role will demand you to learn about hardware and the software components of the network, right? Okay, so if no questions are there, I think we are good to end the call.